Next, I want to look at two well-established best practices for making your code easier to modify, easier to maintain, and easier to use by other members of your team. Studies have shown that in the long run, it costs much more to modify and maintain code than it does to initially create the code. So, these practices are very important. The first idea is that instance variables should always be private, and they should be hooked to the outside world with accessor methods, methods that start with the word get or the word set. This best practice is so well established that it should be considered a law. If you write public instance variables that can be modified, they're not constants, and you try to do this in a real application, in a real program at your job, the Java style police will break into your apartment at night, clap you in irons, haul you away, and throw you into COBOL purgatory. This is absolutely established as a law. You should always follow this principle. Instance variables should be private. If you want to make them modifiable, hook them to the outside world with methods. The second principle, which is almost as well established, is use comments that are marked in a special format for online documentation, and start putting in those comments from the very beginning. Don't write your code, debug your code, test your code, and then a year later come back and put in the comments. Now, end user documentation is a totally different thing. That can be done after the system is developed, and that's not intended for another programmer. But the documentation that I'm talking about is documentation that will help the other team members on your team use the classes you write. That documentation should be at least initially developed from the very beginning, and you should flesh it out as you go along. So here's a quick example. Java documentation is documentation that starts with a slash and then 2 stars. And it typically has a short summary at the beginning followed by a period. Then some more detail. And inside of the documentation, you can use HTML tags, such as images, links to outside sites, even links to videos if you want to explain how the code should run. The second point, make your instance variable private. But if it's private, how can the outside code use it? The answer is hook it to the outside world with methods that let the other developers look up the value or modify the value. So, as we saw earlier, the first goal of object-oriented programming is to avoid needing to repeat identical or nearly identical code. But the secondary goal of object-oriented programming is almost as important. You want to limit the ripple effect. You want to make it so that internal, small, inconsequential changes to your classes, changes that don't affect the outside behavior of the class and don't substantially affect the performance, should be able to be made without other users of your code knowing or caring or changing their code at all. And this idea of encapsulation, making the instance variables private and hooking to the outside world with methods, supports that goal, limit the ripple effect. So the perhaps number one main primary goal of object-oriented programming is don't repeat yourself. Reuse the code, don't rewrite the code. Because if you keep rewriting identical or almost identical code, and then you change your mind, you're going to have to change a lot of things, and these things will multiply exponentially. The secondary goal is to limit the ripple effect. And from a basic point of view, those are the two main object-oriented programming principles. However, there are more advanced object-oriented programming principles that once you gain experience, you might want to take a look at. And the most well-established and well-accepted advanced set of principles is SOLID, which is an acronym for, instead of just 2 main goals, 6 goals. And I commend you to those websites for more details. Let's apply these 2 best practices to our ongoing ship example. The first thing that we do is we make our instance variables private. But if they're private, then code on the outside can't access them. So what's the point? Well, you can hook them to the outside world with methods. So code on the outside that wants to look up the exposition can call the method. And code on the outside that wants to modify the exposition can call the setter method. Now, just as with constructors, it's common but not required that the name of the parameter match the name of the instance variable. This is certainly not required, but if you follow this practice, then you'll need to do what we did with constructors, which is you'll need to resolve the name conflicts. And so you can use the this reference, the this variable, just as we did before. So this.x refers to the instance variable. X here refers to the local parameter. If you don't understand that, that's okay. You just name the parameter to your setter method a different name than the instance variable. Okay, so the first thing I do is I make my instance variables private. I hook them to the outside world with accessor methods, typically that start with the word get when you look up the value and start with the word set when you modify the value. And then I use javadoc documentation that starts with 2 stars. The first sentence will become part of the summary, and then the entire documentation will be shown when you click on the summary at the top of the javadoc screen. And the point of this documentation is to explain to other users in your project how your methods should be used. It doesn't help very much if you name your method getX and your documentation says gets X. Well, you can tell that from the method name. The users of your code will already know the method name. So explain things that are not obvious. For example, what units is it in? Is it nautical miles? Is it in meters? Is it in feet? Is it in latitude? Is it in longitude? That's not obvious from the name of the method. What about the range of values? Can you supply negative values? Is there a limit on your map on how far the ships can go? What happens if you supply a negative value? If it takes an object as an argument, what happens if you supply null? Can it ever throw any exceptions? In which situations? Those are the kinds of things that you should document. So start off with at least brief documentation, but fill it in as you go along and think about what kinds of things would not be obvious to the other users of your code who are on your project. All right, the test routine is also a class, so it should also have Java documentation. And you put this documentation above the class definition and above anything that's public. Obviously, instance variables are not public, so they don't need the documentation, but methods and classes do. And as I mentioned earlier, you can put HTML inside of your documentation so that when it gets generated, there'll be links or images or even videos inside the documentation to help the understanding of the other users of your system. When you run inside Eclipse, you'll execute the code the same way you did before. Right-click, Run as Java Application. You can also build the Javadoc documentation inside Eclipse by going to the Project menu and clicking on Generate Javadoc. You can also generate Javadoc from the command line using the Javadoc command line tool. And once you've done that, and you take a look at the documentation, it will look amazingly familiar. This looks just like the online API that I told you was so important to bookmark when you first downloaded Java. And it's not surprising that this looks similar because the online API, the official documentation for all of Java SE, was itself built with Javadoc. The authors documented the public classes, they documented the public methods, they documented the public constructors, they ran Javadoc on the entire giant project, and that's the online API. You should do the same. Suppose someone comes up to you and says, hey, if you do such and such, your code will be shorter and simpler and will run just as fast. You should say, hallelujah, sign me up right away. But now suppose someone says, hey, you should change such and such and replace it with something else that's much longer and more complicated. You should say, convince me why first. So replacing a public instance variable with a combination of a private instance variable, a getter method that returns the value, and a setter method that modifies the value is substantially longer and more complicated. So there better be very strong reasons for doing this. Fortunately, they are. So this approach of private instance variables and accessor methods is called encapsulation. I'm going to summarize the benefits of encapsulation, and then I'll give you an example to try to illustrate those points. So the first point is that if your instance variables are public, and you change the name of the instance variable, or you change the type of the instance variable, or you change the way the data is stored internally, all the users of your code, all the people who call the instance variable on your class are going to have to change your code. But in many cases, if you hook the instance variable to the outside world with accessor methods, and only the accessor methods are public, you can change your internal representation, modify the body of the accessor methods, and the calling code won't have to change at all. If your instance variable is public and it's of type double, the only thing Java will check is that the callers of your code, the users of your instance variable, try to assign to it a double. You can't put finer grained restrictions. You can't say it has to be positive, it has to be less than 10. You can't do that, but you can do that with a setter method. You can check any values and enforce any restrictions that you want. And finally, you have a ship simulation system. Somebody else on your project modifies the X position of the ship. They forget to then modify the position on the map. So the actual position of the ship and the picture on your graphical user interface are out of sync. But if the only way to modify the X position is to call the setter method, you can put the update to the map in the setter method, and now automatically, whenever the X position changes, the graph changes. And as we said before, you should do JavaDoc from the very beginning. You should mark comments with 2 stars and put those before anything that's public, a public class, a public method, or a public constructor. And then you can run JavaDoc from the command line, or from Eclipse, go to the project menu and generate JavaDoc. All right, let's try this out. So let's try making a class to represent a circle. File, new, Java project. Maybe I'll have other shapes like circles and squares and rectangles later, so I'll call it shapes. Then I'll make a package. Right-click, new package. It's common to name your package after your company or your department or project name. And I'll right-click, new class circle. And suppose I want to do some sort of mathematical operations and calculate the area and the radius and the circumference and things like that. So I'll say that, well, what uniquely identifies a circle is its radius. So I'll make a instance variable called radius, but from the very beginning, I'll make it private. And then if I want to let outside code access the radius, I hook the instance variable to the outside world with a method, typically starting with the word get, public double get the radius. We'll see shortly that Eclipse also has some shortcuts for building these access methods, but let's do it ourselves the first time. And we'll return the radius. And if we want to let callers of our code modify the radius, we'll use a method starting with the word set. Public void set the radius. Pass in a radius. I'll deliberately use the same variable name to emphasize what I'm doing with this. But then I have a name conflict, so I'll use the this reference to resolve the name conflict. This.radius equals radius. All right, and I probably want some methods to calculate the area and other properties and a constructor, but I believe in incremental development, so let's stop here and try it out. Right-click, new, class, perhaps I'll call it circle test. I'll give it a main method to try things out. I hit control space there. Circle C equals new circle C dot set radius 10.0. And then I'll print out the radius is plus C dot get the radius. And it seems kind of obvious, but it's really not. I'm calling a method to set the radius and a method to get the radius. Well, maybe I wrote the methods wrong. Maybe when I called set radius, it stored it in one place, and get radius returned something different. So it's definitely worth testing this. Right-click, run as Java application, and sure enough, the radius is 10. All right, that's what I expected. Now let's try calculating the area. Public double get the area. The area is uniquely determined by the radius, so the getter method doesn't take any arguments. It'll return pi r squared, math.pi times the radius times the radius. try that out. I deliberately used a radius of 10 so that I could compute the area in my head. 10 squared obviously is 100, times pi is 314 point something. So if I print that out, Control C, Control V, oops, an S, the area is, and right-click, Run As, Java Application, and sure enough, 100 times pi. All right, and then we'll put in a constructor. It's pretty conventional to put constructors at the top. Public circle double radius. I did deliberately use the same name as the instance variables to emphasize what I'm doing with it. This dot radius equals radius. Control space. As soon as I save this, then my tester class will be illegal because it's no longer a zero argument constructor. So I'll take the value here and I'll put it in the constructor. I'll run it, verify I get the same answer. At this point, all I've done is a more complicated version of what I was able to do in the previous lecture. I've just done it in a more complicated and longer way. What's the benefit? Well, we said there are 3 benefits of encapsulation. Benefit number 1, you can change your internal representation without the callers of your code changing their code. Benefit number 2, you can put constraints on values without the callers of your class changing their code. And benefit number 3, you can do side effects without the callers of your class changing their code. So let's try each of those. So suppose you decide, I actually use the diameter more often than I use the radius. So I don't want an instance variable called radius. I want an instance variable called diameter. Well, if the instance variable had been public, you'd be dead. All the callers of the radius variable would have to change their code. But now I can change this, and then I can fix my internal code in my methods so that it uses the diameter instead of the radius. All right, so I said that the constructor takes the radius, but I'm going to store the diameter. So I'm going to say the diameter equals the radius times 2. And I can still get the radius, and it'll just return the diameter divided by 2. And if I try to set the radius, I can still do that. It'll set the diameter to the radius times 2. And, oops, I made a mistake here someplace. Math.py double radius equals diameter divided by 2. I can save that, and I go back, and let's make sure that I still get the same answer. Right-click, Run As, Java Application, and I still get the same answer for the radius, and I still get the same answer for the area. So I changed my internal representation in a way that didn't affect the behavior and didn't substantially affect the performance. None of the users of my class have to know or have to care. The second thing I can do is put constraints on values. What would have happened if the radius was negative? Well, that doesn't make sense. How can you have a negative radius? It just doesn't even make sense. But Java can't enforce that merely by having an instance variable. But you can enforce that in your code. So in my setter method, I'll say the diameter is the absolute value of the radius times 2. And so if they pass in an absolute value, a negative value, it'll still use the positive value. And I'll do the same thing here in the constructor. And so now in my test routine, if I pass in a value of negative 10, it should actually store 10, not negative 10. Let's try it out. Right-click, Run As, Java application. Sure enough, even though I passed in -10, I got 10, and I got the same area as I did before. And then finally, you can do side effects. So suppose that you have some simulation system where the areas of the circles are calculated very frequently, and the radius of the circle, or the diameter of the circle, is changed very infrequently. Now, don't try low-level optimizations like this unless you have some profiling, some benchmarking that shows that it actually is a performance drain. But suppose that you've done some benchmarking and you've shown that your innermost loop keeps recalculating the radius so many millions and billions of times that it's actually costing you something. And so you want to say, I'd like to pre-calculate the area. I'd like to make the area an instance variable. And whenever somebody asks for the area, I just want to return it. Well, this would be absolutely impossible if the radius or diameter and the area instance variables were public. There would be no way to enforce that the area and the diameter stayed in sync. Users of your code could modify each of those instance variables separately. But if the only way to change the radius is by modifying it through a method call, then you can enforce that it stays in sync. So let's change this method from public to private, and let's call it calculate area. And we'll have it return same thing that we did before. And then I'll add in private double area. And then in the constructor, I'll say that the area equals calculate the area. So I just set the diameter, and then I set the area based on the diameter. And then in my setter method, I can do the same. Control C, Control V. And now I could have an accessor method, public double get the area, that just returns the area. So the only way you can set the radius is through the constructor or through the setter method. And when you do it through the constructor or the setter method, it modifies the area automatically as a side effect. So let's try this out. Right-click, run as, Java application. But if I really want to test this properly, I ought to change the radius and see if I still get the right answer. So I'll do c.set radius, and we'll make it maybe 1.0. And then I'll print out the area again. And it should now be pi. And sure enough. Okay, so the three benefits of encapsulation, of making your instance variables private and hooking them to the outside world with methods were, 1, you can change your internal representation. So I changed the instance variable from radius to diameter, and the callers of my class did not have to change their code. Secondly, I can put restrictions on values. I could say that the values cannot be negative. I couldn't do that with public instance variables. And thirdly, I can do side effects. Whenever you change the radius, automatically pre-compute the area and guarantee that the pre-computed area and the radius are always in sync. These benefits are so large, so critical in the cost of modifying and maintaining your code, that you should consider it an absolute law. Any instance variable that can be modified should always be private, and you should hook it to the outside world with accessor methods. Do that from the very beginning. Do that always. All right, I also should do some documentation. So I should say represents a circle that has a radius and an area. The whatever units you pass in for the radius, e.g. feet, will be reflected in the area, e.g. square feet. And I will worry about these other tags later. And then I should say returns the radius, which is half the diameter, and so forth. All right, but notice in particular that for the circle, the Javadoc documentation at the top has two sentences. This is the first one, and Javadoc actually looks for that. The first time you have a period followed by a space, that becomes the summary. And then the details will follow. So let me try the same thing over here. And we'll copy that. Control-C, Control-V. Builds a circle that has a radius and an area. And now let's generate the Javadoc documentation. So I go to the project. I go to generate Javadoc. I make sure that it knows where Javadoc is. It's going to automatically put it in the doc folder in my project. I say OK, yes. And then inside of the doc folder, I can go to the index file, drag that into a browser. I can click on circle, and notice if I go to the constructor, in the summary it says builds a circle that has a radius and an area. But if I click on that, it shows me more information. Builds a circle that has a radius and area and whatever units, blah, blah, blah. So for all of the constructors and methods that are public, the first sentence, the documentation up to the point that you have a period followed by a space, goes in the summary at the top, but when you click on it, it shows the full detail. Also notice that the Java documentation shows the other users on your team that use your code the names of the variables. That's why it's useful to use the this convention, where the argument to the constructor has the same name as the instance variable, because it makes it clear to the users of your code. These are not end users. These are developers on your team. To the users of your code, what you're doing with that. OK, so the two best practices are, 1, make your instance variables private and hook them to the outside variable accessor methods. 2, use Javadoc documentation from the very beginning. It seems like a lot of effort, but once you get used to it, it's not very much additional effort, and it pays off 5-fold, 10-fold time in the life of your project that you should consider it a law. Make private instance variables and accessor methods, in other words, use encapsulation, and start at least brief Javadoc documentation from the very beginning of every class that you ever write. All right, before we stop beating this dead horse on accessor methods and getters and setters, 3 more points. One is using accessor methods is not as much extra work as I implied. Everybody does it this way, so every development environment, including Eclipse, has shortcuts for building getters and setters. Secondly, you don't have to have getters and setters. It's perfectly possible to have a read-only property where you have a getter but no corresponding setter. And thirdly, there's no requirement that the name of the method, which is what people who call your code see, and the name of the instance variable, which is what the internal code uses, be the same. Let me illustrate. All right, we saw earlier that Eclipse could help you build constructors. So go to the source menu, generate constructors using fields, select the radius, OK, take out this bogus thing here. We'll see what that is later, but even once we understand it, we won't want it. We've got a constructor. But Eclipse can also help you build getters and setters. Go to the source menu, generate getters and setters. I can expand this and choose which one I want, or I can select them all. and it builds the getters and setters for you. Here's the getter, and here's the setter. And notice it builds the getters and the setters in the same way that we would have built them ourselves. All right, that's a good thing. The next point is that you're not required to have both. You could have a get radius and no corresponding set radius. So the callers of your code pass the radius to the constructor, and it never can change again later. In fact, if you want to enforce that it can never change again, you can say private final double. An instance variable that's final can be assigned to once and never again. And so you assign to the radius in the constructor, and it can never be changed. And if all of your instance variables are final, then the state of the object can never change. That's called its immutable. Immutable classes are very useful when you get to multi-threaded programming, so that two different threads are not updating two different pieces and giving you inconsistent results. So this is actually quite a common approach where you have a read-only property that's set directly or indirectly through the constructor. You have a getter method but no corresponding setter method, and you mark your instance variable as final. Lastly, there's no rule that says that the instance variable has to match the name of the method. So I could go here and I could right-click, refactor, rename. That means it changes it throughout your code. And let's say I want to call it R, because pi times R is clearer when you're writing an equation than pi times radius. But people call your code. They don't want to use R, they want to use radius. So I change the name of my instance variable, but I don't change the name of the method. And so this is perfectly legal, and there's no requirement that the name of the method has to match the name of the corresponding instance variable. In fact, callers of your code don't even know if there is an instance variable. In the previous example, we had a method called getRadius, and we had a method called getArea. It wasn't clear to users of your code if getArea corresponded to an instance variable or to a calculation. They shouldn't know, they shouldn't care.